Thank you very much for attending the session, Effective Production Planning and Scheduling with Standard Tools in SAP ERP. This is a re-recording of a session and a presentation I gave at this year's annual Users Conference of SAP, Sapphire, and ASUG in Orlando on Wednesday, May 15, 2013. So the presentation breaks down into three parts. I want to first ask the question, why should we even plan inside of SAP our production schedule? There's a lot of companies that I've seen over the years that move outside of SAP for various reasons, mostly because they don't think there is enough capabilities inside of SAP with the functionality that is provided that gives them enough functionality to do a good, effective production schedule. But we're also going to be analyzing a couple of generic problems that are occurring in that area. Then we want to move on and look at a more or less scientific approach to evaluating our supply chain and deciding whether we need to do something in production scheduling, whether we need to do an inventory reduction. All those questions are going to be answered if we can look at a model and evaluate where we're standing in the supply chain, how effectively we're moving inventories through it, and how much we achieve a product flow. And then last but certainly not least, look at all the options that are available in standard SAP to schedule a production line. To me, a supply chain is like a pressure system. You have your flow going on, you have your transformation. Your flow is restricted by certain things that you can actually control and regulate the flow with. You have your purchasing, your amount of orders, your order rate that comes in. You have your production scheduling that we mostly will talk about here, which is another level. And you have your sales flow, which is the one that you can least control. What's going out in terms of orders, but it nevertheless is a flow that can be controlled, and depending on how you control it, you will either build up inventories, or you will build up time, or you will be restricted by capacity. So when you start applying pressure from the upstream side of the supply chain, from the raw materials, for example, and push it all the way through to the levels, what's going to happen is that you're building up inventory everywhere where the flow is being restricted and cannot flow freely. Now, the opposite is true if you apply pressure from the other side of the supply chain, from the downstream side of the supply chain. If you're pulling from the sales side, then your inventories will go away. However, there will be time buffers that are building up. If you have a pure pull system, you have to allow time in the supply chain to pull the material through. You're not building inventory as a buffer, but you're building time as a buffer. That is also, by the way, the main difference between MTO and MTS. And most of you probably don't use either one of those systems in its purest sense, and have something like an inventory order interface in the middle. So this is basically a combination between push and pull, and what we can do here is we can reduce the lead time through the entire supply chain by pushing from the raw material side through the levels and building up some inventory that serves as a buffer, and then we can pull from the sales side of the supply chain, and we can pull from inventory. That reduces the lead time to the customer, but it also gives us some inventories. So a careful balance has to be created between that pull and that push system, and very often it is achieved with an inventory order interface. Now let's move on to the demand side of things. Of course, in order to schedule production, you need some sort of demand, and you need to know what you need to produce in order to fulfill some sort of demand. In a make-to-stock situation, therefore, logically, we have some planning going on and some forecasts that we're going to tell our production department so that they can approximate what they have to do at what time, in what quantity, for what place. Now, usually that's in form of a forecast that's going to get released onto the production line at any given point in time. Then what I see a lot happening is that sales orders are coming in. They are not necessarily correctly consuming a forecast that was put in place for it, but the salespeople usually just moving any demand over to the production department, and the production department then naturally is very overwhelmed with a lot of orders coming in. So what we're recommending here is to implement some sort of a gate control system where you're moving demand through different capacity checked gates, and you're making sure that in the end the production scheduler gets some demand to deal with that they can actually fulfill. So the first gate is at the sales and operations level. We can perform a rough cut capacity check, then we move that on to our strategic materials planner. The strategic materials planner would then go off and perform a segmentation of all the products, decide on MTS versus MTO versus assemble to order, and would move that demand directly to the production scheduler, and then there would be some sort of a feedback system back to a tactical materials planner who would perform expediting functions. So in its essence, don't just drop demand randomly on the production planner. Introduce some sort of gate control and give the production planner something to work with. Production scheduling is at the heart of the delivery cycle. As we have a demand entry, whether that's a forecast or an actual customer order, we go through, if it's a forecast, we go through planning, and then we go through scheduling, where we actually come up with a finite plan, to execution, to execute on that plan, on that schedule, and put stuff into stock so that we can deliver it to the customer. But we have to be very careful that we don't mix and match different products, because there's make-to-stock products and there's make-to-order products, and it is a very distinct difference between the two. I call the MTS, the make-to-stock cycle, an open loop, because you have your customer forecast and you're always going to put that forecast into the system as a demand, and you're always going through planning, and you can plan way ahead as long as the forecast goes out, and then as you come into the shorter time frame, you're going to put together a schedule, and then you execute, you put the product in inventory, and you deliver to the customer from inventory. This is very different in a make-to-order environment, where you have something like a closed loop. After your demand entry, that doesn't come from a forecast, that comes strictly from a distinct customer, you're skipping the planning phase, because there is nothing to plan. All that there is to do is to put that customer order onto a schedule, and you have to be carefully planning for these make-to-order products to be able to be scheduled on the plan. Therefore, you should never plan to 100% capacity, but leave some room for make-to-order items. But what's important to note here is that we are not planning for make-to-orders, and we are not putting them in inventory either. We simply put the demand right onto a schedule, we execute on that demand right in the schedule, and we deliver right from the execution. We're not going through the stock. All that stuff is very important, and it's forgotten so often. I see availability checks where the customer sales representative does not know whether this item that they are discussing with the customer is a make-to-stock item or a make-to-order item, and the availability check doesn't know whether it's a make-to-stock or make-to-order item. And sometimes for a make-to-order item, people look at inventory, or the availability check looks at inventory, and tells the customer, oh my God, we don't have it in inventory, and the customer says, but I want it right away, and then there's a discussion back and forth, when there actually shouldn't be a discussion, because if it's a make-to-order item, there shouldn't be a discussion about whether it's in inventory or not, because it shouldn't be in inventory. And if it's a make-to-stock item, the item should be in inventory, and if it's not found there, the customer will have to wait until after the replenishment lead time when it can be delivered. And very often what I see is that customers actually agree on a 2-week delivery time, but the availability check and the sales representative are transferring the demand right onto the production line, and the production scheduler is told to make the product as soon as possible, even though it's not in the plan, and it was always planned to be available only after the replenishment lead time. And even the customer is agreeing to the lead time, but the demand in SAP is actually not representing that. Now, if you're looking at only production scheduling, all there is to do and all that should be happening there is pooling, leveling, and sequencing. So then the production scheduler's task is to take that pool of orders that was generated and coming out of MRP or otherwise and open up the floodgates. Now, when the production scheduler opens up the floodgates, it should be ensured that a rough capacity check has been done beforehand so that there is not too much coming at the lines. And then we'll take all those orders and we distribute them accordingly onto the right lines in the right mix. Note that the line on the upper right side is a mixed model line. That line, besides being capacity leveled, also needs some sort of a sequence for the various products that are running on that line. So what these production scheduling methods should be doing, it should be helping the production scheduler to find the right mix here and to direct the supply, the orders onto the appropriate line, and it should do so in an automated fashion. And that's what we are talking about here. What are the options in standard SAP ERP to do exactly that? The basic principle of production scheduling is to take the vast amount of orders in the pool and to sequence them out over the lines. Now, that is a problem in itself if you look at the vast amount of possibilities you have to build a sequence. Imagine you have one workstation and you have 3 jobs running on that workstation. Now you have 6 possibilities of putting these orders into a sequence. You can first do A and then B and then C, or you can do C and then B and then A, or you can do A and then C and then B. You do have 3 factotum possibilities, 3 times 2 times 1 possibilities to come up with a sequence. Now, if you have 25 jobs running on that one workstation, you have 25 factotum possibilities, and that translates into a number that, if expressed in pennies, it would cover the state of Texas 6 miles high. So that is a problem that we usually cannot solve that easy, and certainly things like what most people think that APO is going to solve all these problems with heuristics, that's not happening either. So we need to find a different solution to the problem, and it's certainly not a mathematical solution and a powerful computer system that finds the best sequence out of the huge amount of possibilities. It's probably lying there in a different area where, for example, we can think about a pool system, or we can balance the line, things like that, but we'll talk about that in a second. Then there is the problem of communication. If sales is the only department in your organization that puts together a forecast and does not perform a rough cut capacity check, and does not make a difference between what's make to stock and what's make to order, and does not configure that into the availability checking rules, then your production planner probably has a big task at hand that's basically unsolvable. It's very important that the production schedulers would participate in at least some of these meetings in order to bring in the constraints from the production floor, for example, and a lot of other things, so that we can have a consensus forecast and not just something that fulfills the demand that we have coming probably from the customers. Because there need to be some decision being made. If the forecast is so high that that we can see, and we should see, that the production lines can't handle it, then we have to do something before we hand over that forecast. For example, we would have to maybe go to our executives and ask for more capacity. However, if we do have that agreement with sales and with everybody else, and we have a long-term plan and a mid-term plan, then we should also come up with a short-term plan in production scheduling. So we have to put some release strategies together. We have to fill a toolbox, if you will. A toolbox that allows you to flexibly act to any changing situations. If you don't put that toolbox together, if you don't put that playbook together, you're forced to use the same method every single time. And as we all know, the situations are changing all the time. We sometimes we have undercapacity, sometimes we're way over capacity, sometimes we need to sequence the orders in a different way. You need, for those different situations, you need to put yourself together a playbook that's using all the methods that are available in standard SAP ERP, because one size does not fit all. There's so many different possibilities in SAP to schedule your production lines in an automated fashion, but not every method is the right fit. And what I've seen in most companies, they are using one method, and they're applying that to not only every production line and every plant, but also to every level of that production line and production process. What we've been doing at some of my clients is that, for example, if they have a line that produces some sort of, let's take cheese, some sort of bulk product, the way to produce the bulk is certainly some type of processing. So process order scheduling would be in order for that. But when you look at the packaging line really doesn't need any process orders. And a repetitive scheduling method using run schedules would be a much better fit there. So then you can have Kanban in the middle somewhere. You can have a Conweb process somewhere. There's so many options. The basic thing is you need to pick the right method for the right situation. And if you think about all the things that are impacting production scheduling, from purchasing through distribution, the customers, the variability that's in place, and all the things that are impacted by the way you're scheduling production, whether that's the quality, whether the bullwhip effect that you might be causing, equipment utilization, the service levels, and the fill rates that are definitely being impacted by the way we are scheduling production, then it becomes very apparent how important it is to have a sensible production schedule and to actually act accordingly and execute to it. So now let's talk about the second part of this presentation in preparation for the third, and when we talk about the various scheduling options. In the second part, I'm giving some ideas on how you could measure your production scheduling system so that you can, based on some scientific facts, that you can decide what kind of methods would work in what situation and therefore build your playbook. First of all, there's a vast amount of information freely available in the LIS or in other areas of SAP ERP. There's, of course, you're probably familiar with the capacity utilization graphs and tables. There's information in the work center for standard available capacity that very often needs to be cleaned up so that it correctly reflects what's going on the line and how much capacity we have available. There is, if you look at the graph on the lower left, there is a graph that shows what was the planned start and end times, and that's represented by a white bar for any given order, and what were the actual start and end times. So you can see on the lower right here that this particular order was planned to be started at this day, and it was planned to end at this day, but in actuality it was started right when it was actually supposed to be finished, and it took about 3 times as long. Then there is the subject of segmentation. You might use segmentation to classify your raw materials and your finished goods, but in my opinion, you should do something very similar to your production scheduling method. This is the first step in finding out what's the ideal scheduling method for my situation. You see on the left here, we distinguish between processing types. What industry are you in? What processing type are you executing on your shop floor? Is it a jumbled flow? Is it a discontinued line flow? Or is it even a continuous flow like a process line? This continuous flow does not only happen in process manufacturing. That's something to note. It's supposed to happen in the automotive industry, for example, where we are supposed to have continuous flow lines. Now, if you look at production volume and mix, you're looking at do we have very variable finished products? Do we have a lot of variety in our finished products? Or are we producing engineer-to-order items? Depending on this type and production type and production volume and mix, you should look at where should I be looking in my production scheduling method and what can I select and further detail. Another great way to find out where we're standing in terms of how effective we're using our inventories to produce throughput is flow benchmarking. Flow benchmarking comes from the people from factory physics. Spearman and Hopp have written a book called Factory Physics, and one of the methods described in there is, or one formula that's being described in there a lot, is Little's Law. Little's Law relates throughput to inventory holdings and cycle times. And this flow benchmarking graph is a great way to find out where exactly are we in for any given production line. You can do this for the entire supply chain or for just one station. But whatever you do it for, you have to relate, of course, the throughput, inventory, and cycle time figures to that particular thing. So if you're looking at a production line, for example, one processing line, we can see what our maximum capacity is. And that maximum capacity can easily be determined. It's in this example, if we're putting throughput in the dimension of sales and revenue in dollars, and stock holdings, the average inventory holdings per day, and the cycle time, how long it takes to get a product through to sales, then we can easily determine what is our maximum revenue that we can achieve per day, given what we have on the production line and what kind of capacity we can actually fully utilize. That is, if every customer picks up every product we ever produce, and if we're running at full capacity, that is represented by this line. Now, we need a minimum inventory in order to achieve that throughput. If you have no raw materials, no intermediates in the system, you're not able to achieve your maximum throughput. So that is represented by this corner here. If I go down, this is my critical WIP, or the minimum inventory that I need to put into the system to achieve maximum capacity. Anything less than that is drastically reducing your throughput, because like I said before, if you don't have any inventory in the system, you can't achieve much throughput. So if we are creating this black line here, and we're assuming a lot of variability, and variability is always present. Sometimes your suppliers deliver raw materials too late, so you don't have that stuff that you need, or you have the wrong inventory at the wrong time, at the wrong place, or your customers do not pick up every product that you're manufacturing, or your production line breaks down and you can't produce at full capacity. All these things are variability, and the more variability you have, the more you come down from this maximum line here. And this is a line that was plotted here, assuming a lot of variability. So if you find yourself, if you look at what average inventory am I holding at any given day, and what kind of throughput am I achieving on average on that day, you find yourself somewhere here. If you find yourself above the black line, and you can't be above the red line, but if you're finding yourself between the maximum and the practical worst case, which is represented by that black line, then you find yourself in the lean zone. Now, if you look at that black line, the practical worst case, and you find yourself at point 1, you could take an initiative to reduce your inventory holdings. That initiative would move you from point 1 to point 2. And now, because that practical worst case line is pretty flat at that point in time, your inventory reduction would result in only a little loss of throughput. However, if you find yourself today on point 2 and you further reduce inventory or WIP that's needed in the system to achieve throughput, then that line gets steeper and steeper, and you would lose a lot of throughput with every inventory you're reducing. So a blind reduction of inventory is sometimes a very dangerous thing to do, and that kind of initiative should be taken very carefully. But if you find yourself at point 1, an inventory reduction is absolutely in order. However, in order to get into the lean zone up to point 3, you need to do something else, and that kind of thing is usually a reduction in variability. And one way to achieve reduction in variability is to optimize your production scheduling to get a more leveled production schedule that makes sure that you're producing the right material at the right time in the right quantity. Lot sizing optimization, setup reduction, all those kind of things reduce your variability and move you from point 2 up to point 3 into the lean zone. And it is another thing, it also moves you above the demand line, because that demand line could be your actual demand or your forecasted demand, and that is something that is obviously should be below maximum capacity. Maximum throughput that you can achieve, but it should be somewhere where you can achieve it. And you should actually achieve it. You should use your inventories in the system and your available capacity to the degree that you're producing to demand. Not much above it, that doesn't make any sense, but if you're below it, you can't fulfill your customer orders. So this is a great way to see where you're standing, and also helps a lot in the decision making of what kind of initiatives are we actually pursuing in order to get better, and which ones will actually help us and which ones will be detrimental to what we actually want to achieve, like a blind inventory reduction when it's really not necessary. I've seen in some companies, I've seen where we find ourselves way to the right, and we're using way too much inventory to achieve the throughput. That's the more common situation where we're covering our problems with too much inventory. But I've also seen production lines where we were all the way to the right and all the way down at only little throughput, because we have not enough inventory that we can actually fill our lines. In that case, inventory reduction really doesn't make any sense, and we need to take other initiatives. So it's a great way to see what we need to do. Another thing that I find extremely helpful is laying out your value stream. If you look at a value stream, you always have your materials flow going from supplier to customer on the bottom, and you have your information flow going the other way on top. If you include your sales and operations planning, MRP, procurement and distribution, and of course production scheduling in your value stream, and you create an SAP value stream map, you can put all kinds of information on that map. Here's an example of such a map. The value stream map starts with the supplier, and you can see the material flow as it goes through various inventory points. At every inventory point, we have identified the material master record with its specific settings. We have all the workstations listed here. We have identified what workstations, what route does an order span. We even have, if you look at the red boxes, we even have some configuration information in there. We identify what kind of scheduling methods we're using, what we could be using. Is it Kanban? Is it repetitive? Is it CM25? And for every transaction, we can give a description as well. How do we go into the transaction? How do we execute it? So these value stream maps give you, these SAP value stream maps give you complete information about the current situation, and then you can model your future situation and create a future SAP value stream map with all the information that you need to communicate throughout the team. I usually start out with the basic value streams. There's one for make to stock, there's one for make to order, and I also use one for finish to order, or finish to stock, or assemble to order. That I usually start out with. This is my beginning, and as you can see on the basic value stream for make to stock, we're pushing our materials through the material flow into finished goods inventory, and from there the customer is going to pull. Very short customer lead time, but potentially a lot of inventories. And here you can see the make to stock basic value stream mapped out. We can even put the flow benchmarking on the upper left here so that we can see where we're standing for that specific value stream. Then there is our basic make to order, where the customer order pulls all the way back from the raw materials inventory, and in extreme case even from the supplier. And here's your value stream map for that. As you can see here, there is, on this value stream, there is no sales and operations planning, because we are not going to put a forecast on a make to order item. So production is scheduled based on customer orders coming in. And then our assemble to order or finish to order value stream, where we have an inventory order interface that's being placed strategically at the right place. To the left of it, upstream of the value stream, we're pushing material into inventory, so that to the right or downstream side of the value stream, we can pull from that inventory and finish the product up, maybe package it or do some final assembly onto it. And here's the value stream map to that. As you can see in the middle, MRP drives somewhere in the middle of the value stream the production schedule, and you're pushing to the left and you're pulling from the right. The inventory order interface is a great way to combine make to stock and make to order systems, so that they can be used in the same system and be combined. I explained this before. There's push from the upstream side and pull from the downstream side. You have to take very good care of where you're placing that inventory order interface. But that can be beautifully done, analyzing a value stream map and strategically setting that point. In our SAP value stream map, we can also identify how we set up our master data, not only for materials but also for work centers and bills of materials, routings. Everything else we have in the system can be identified as is, and then we can work on the to be and put out whether this material should be a PD, a reorder level procedure, what kind of lot size procedures we're using, and so on and so forth. What's important to note is that everywhere where you have inventory, not WIP, but actual inventory, there you should have a material master code for it, and therefore you have a material master record. So at every inventory point, you can fill out one of those boxes and improve your materials flow by the right settings and the right strategy and policy in the material master record. And we can also identify in the SAP value stream app the process, how we run through the process, how we execute transactions, how do we use sales and operations planning. Something that I like to put in there is that we're performing a rough cut capacity check inside of sales and operations planning, and how you want to do that you can describe right here in the value stream app. So it's a great way not only to determine what our system setup is going to be in terms of master data, but also how our user should use the process and the transactions and go through the flow. Rough cut capacity planning in sales and operations planning, very important in my mind. It's this first gate control, the first gate your demand goes through, and it should be leveled there already, to at least to some degree. What you can do in standard S&OP, in ERP, you fill out these planning tables on any level of the planning hierarchy. And what I see very, very often is that a forecast is being maintained in that line, sales. Now, that line should represent the numbers that you want to sell in any given period, but those are not equal to the number of units you should produce in that period. Therefore, you should actually execute a standard macro that's in the system that allows you to put in some target day supply as a safety, and then run that macro, and depending on how much you want to have in safety at the end of the period and how much you think you're going to sell, that it tells you through a rough cut planning profile what needs to be produced in that period. Once you know that, the system also calculates a stock level, which you will most likely end up in that period if everything goes by plan. But more importantly, you can perform a rough cut capacity check on those production numbers right here in this table. So the system is now looking at the production figures for every period and compares what we have in terms of available hours on that line where these products are being manufactured. So from month to month, through a statistical work center, you can provide this table with an available capacity in hours. And the system can figure, based on the quantities and based on a rough cut capacity profile, how many hours are required to produce the requested production quantity in line 2. And then the system will compare those two figures and will tell you what the utilization will be then. This way you can avoid transferring a demand to the production scheduler that's at 400% of available capacity. This is also a great tool to go to your executives with and ask them for more capacity if they want to keep the sales figures. So the entire supply chain is mapped out in your SAP value stream app. There's a place to maintain information for sales and operations planning and MRP, purchasing, sales, of course scheduling, but also for execution and confirmations and how you want to execute on that. And here you have the final chart, maybe a 2B chart, according to which we're executing our initiatives now and select production scheduling methods. Lots of information on there, lots to discuss about. And here it is. You can, of course, put notes on there, identify your initiatives, identify your constraints, see what the specifics are. A great place to serve as a basis for any discussions you might have about any improvement projects, and to identify what kind of scheduling method we're using at what place. But I also like the three-dimensional models. I like Lego. With Legos you can build a three-dimensional model that represents, for example, your production lines. And this is the kind of thing that we very often refer back to when we want to change things, when things don't work the way we want it. We go into these Lego models, discuss it, move things around, play with the bricks, identify where the inventories are, where's the bottleneck, what specifics are happening at what place. And then we map the value stream right onto it. In this case, you can see what kind of periodicity we have here, and how production scheduling works today. You can see 4 arrows going down to various stations on the line. That means we're scheduling at 4 different places. We have inventory at 5 different places, and then we can move over to the 2B value stream map. We can eliminate inventories by introducing of a pull from a repetitive line, for example. We can identify Kanban as a pull system. We now have one place where we schedule, and that is the bottleneck. So we're pulling from the bottleneck and making sure that we're pulling through the bottleneck only that's requested and identified through a signal from the pull system. Okay, let's get to the heart of this presentation, and let's talk about the various production scheduling options, at least the ones that I know and have been playing around with and also have been implementing at various customer sites. Lots of these I never see used at the various SAP user sites. Some of these you might recognize, some of them you might not. We'll talk about each individual one and show the basic concepts of them. There is the traditional capacity leveling. That's probably the most used production scheduling method in standard SAP ERP. It's got a Heijunka strategy with it. It's got setup optimization. I have been seeing this being used. There is repetitive manufacturing that was developed in the 90s by SAP to give more options for companies that are producing a product repetitively more than once in a period. In it, there's TAKT-based scheduling of a repetitive line, of course, and there's TAKT-based scheduling for a repetitive line where you can have the actual execution driven by Kanban withdrawals. There is a component forecast and TAKT scheduling of the MRP result that is actually some sort of a trick that you can use in MRP so that the orders are being spaced. Instead of creating one lot that covers the entire demand, we can fix and split. There's Kanban, there's Kanwip, which is a multi-Kanban process, and there's the product wheel that's mostly used in the process manufacturing industry. Before we go into the individual methods, I'd like to touch on 2 points, one of them being autonomous versus central planning. If we want to use an example from the former East Germany, there was the central committee that was planning basically for everything that was going on in the economy of Eastern Germany back in those days. And that central committee has, for example, has told what the butcher needs to put in the shelf. Now, this has not been working out very well because the central committee was really a little bit out of touch on what was going on at the butchers, and the butcher knew much better what they needed to put on the shelf, what kind of sausage, what kind of meat. And the same is probably true with some of your production lines. In some cases, you're probably much better off if you let the people down there at the line who see what's going on, what's going out, what's being consumed, and what's needed, let them decide on how they run their production on a various station, instead of having some planning committee somewhere in Minnesota drive what's going on the production line down in North Carolina. So there's certainly a need for central planning, and I'm not saying everything should be autonomous. and the other way around. But we have to make that decision, and sometimes it's really better if we let the people on the line decide what's going on. And then there's the question whether we should introduce a pull system or a push system. That is also something that needs to be carefully evaluated, and there's also not an all-size fits. Okay, here's the first one of our methods. It's traditional capacity leveling using transaction CM25. I'm sure most of you have seen transaction CM25. It's simply using a pool of orders, a combination of production or process and planned orders, and distributing them according to their free availability alongside a timeline on a production line that is meant to produce these items. The way the distribution or the dispatching is happening is by way of a profile, and you can use the standard profiles, or you can use your own and customize your own. Let's go back to our delivery cycle and see what happens in traditional capacity scheduling through the various phases. Well, in the planning phase, MRP generates planned orders and runs them through the factory calendar. These planned orders have a start and an end date. They don't have a start and an end time yet. And they're being run and scheduled through the factory calendar if we don't use lead time scheduling, and that's what I'm assuming at this point in time. Then as we go to the scheduling phase, meaning we're either performing now lead time scheduling, or we're converting a planned order into a production or a process order and therefore schedule the order. In which case now the work center's available capacity or available schedule takes effect, and therefore when we perform scheduling, the orders will now receive start times and start and end times, of course with the start and end dates. But what's important to note here is that the system is not just simply using the factory calendar, but it uses for each production line and for each work center the available times, the opening times of the work center, if you will, and therefore is able to schedule the orders according to that. But we are not leveling yet to capacity yet. As you can see, production order 2, 8, 3, 12, and 18 are all running on the same day, and there's probably not enough capacity to do that, but that's what's going to happen in the next phase. And here is where the capacity leveling is happening, and now all those orders were taken and put in a sequence, and they were dispatched or distributed on the primary production line until it was full, and then it was switched over to the secondary production line and filled that one as well according to the free available capacity. This is what's happening in traditional capacity scheduling with CM25, and is driven by the strategy you are using. As a variation of that strategy just discussed, we can use a different strategy that we can call setup optimization. You can see in the strategy itself, the setup optimization was checked on, and we can do another thing in order to gain a better overview of what's happening here. We can color code the bars and display the setup time of the setup portion of the bar in a different color than the processing portion of the bar. Wolfgang Bart from SAP Germany has put together an excellent documentation about how to color code bars in CM25, CM29, CM21. So what's happening now is we clicked on setup optimization, and we color coded the setup portion in blue, and we identified like setup operations. So in the next step, all the like setup orders will be scheduled together, and then the other like setup orders will be scheduled right after that. In our case, there wasn't enough room to schedule all orders on the primary production line. So therefore, the strategy in CM25 has scheduled all the light blue setup operations and orders on the primary production line, and the dark blue ones on the secondary production line. To visualize how this all looks in CM25, we have in the order pool, we have planned orders and production or process orders, differently color coded in green and in blue, and we have the respective bars all in the pool at the lower portion of the screen, and we have color coded the setup portion of the bar in blue and the processing portion of the bar in red. And now we will select all the orders in the pool, which makes them turn into the kind of bluish color here, so that you can tell that they are selected. And when you hit the dispatch button on top, you will see that these orders disappear from the pool, and they are being sequenced and scheduled and capacity leveled on the production line resource 200, and you can see that how they are being distributed or dispatched according to the strategy that was identified beforehand. And here we see the final result. You should now be able to release the orders, print the orders if that is necessary, and release them to the line in the order that was dispatched according to the strategy. Moving on to the next method that I have been using, and this is a little bit of a tricky one since it's not actually in the transaction for capacity leveling. This is actually how you can start leveling a production program right out of MRP. And the way this is controlled is by way of the material master record. You see that down here we have in the MRP1 screen of the material master, we have a TAKT time, and you can use fixing and overlapping, fixing and splitting actually, and you could, instead of creating one supply element for every demand element, if you have a forecast out there for every month of 1,000 pieces or 10,000 pieces, you could split the supply elements that are created and time phase them backwards. There is some configuration necessary in the lot size procedure, fixing and splitting, but it can easily be done in the standard. It's set up so that it time phases forward. I suggest you time phase it backward, and by what phase it's being split backwards is determined by the TAKT time. So in the case that we're looking at here, we are splitting the supply elements to cover the total of the demand elements by a fixed lot size of 2,400, and we are splitting it backwards and time phasing it backwards by 3 days. That way you can achieve a somewhat leveled planned order schedule already, so you save some work later on when you do the actual capacity leveling with lead time scheduling. Then there is Kanban. I consider Kanban a scheduling method as well, and Kanban is a visual scheduling method. It's not controlled by MRP or any other planning action. It's an autonomous method. It's not a centrally planned method. It simply says if I have two containers and one of the two containers gets empty, I'm gonna give a signal that the container is empty, and that will trigger the creation or generation of a supply element to fill the container back up. Now, how much you put in each container and how much containers you're having in the Kanban control cycle depends on the situation and the consumption you're having. But what's important to note here is that this is a purely visual system that should not be controlled by any planning method, and it also should not, like I've seen in many cases, be controlled by inventory management. I have seen customers trying to trigger the empty signal by a goods issue transaction. The goods issue transactions are always a little bit off timely, and If you're using that kind of thing, you're losing the advantages of Kanban that will ensure that we're only replenishing if actually something goes out. It's a purely visual system. If the container is empty, we should fill it back up, and for the time it takes to fill it back up, we should have a second container that is full and gets us through the replenishment lead time. This is the Kanban board. You can see as an overview for each Kanban control cycle for any given material, we have empty containers, we have full containers. Whenever a container becomes empty, you have to tell the system that it is empty. You can do that with a barcode scan, you can do it with an RF gate, or you can go into this Kanban board here, click on the Kanban container, and click it to empty. That will then in turn generate a supply element that can be a planned order, a production order, a stock transport order, or purchase order. And that order is then simply meant to fill the container back up. So you're gaining an overview here, what elements are out there and what needs to be replenished and what you have available. Then yet another method to schedule production is what I here call CONVIP. It stands for Constant Work in Process. It's a method that was also developed by Hopp and Spearman in their book Factory Physics. It basically spans multiple Kanban control cycles and allows me to set a container to empty and do all the intermediate steps and products that are necessary to fill up eventually the product that I'm in need for, or the Kanban container that I need. It does so when we use a special procurement indicator that creates collective orders. So when we set that container all the way to the right to empty, and we know we need to replenish that product, but we need two intermediate products before that, the system actually creates 3 production orders and sequences them so that it allows me to use raw materials, create or produce intermediate product 1 and then intermediate product 2, and then eventually fill up the container at the end. So CONVIP is no different from Kanban, only that it spans multiple stations or even production lines and allows me to actually pull something through the system, through the line that has multiple parts in between. And then we have the product wheel concept, a concept that's mostly used in the process industry. It is adhering to lean principles, allows me to manufacture in the smallest possible lot sizes. It is mostly used on mixed model lines where you have to sequence different products to run on the line in the smallest possible lot size, and it deals with setups. And most people think that we always need to do setup optimization. This is doing rather the opposite, by saying that if I have capacity available, if I have capacity left over, I rather waste that capacity on more setup rather than producing product that I don't need and that I don't have any demand for. So the way this is working is you have this wheel that you see in front of you, where we manufacture in one period that could be a day, a week, a month, 3 months, and goes around the wheel once for the period. So in this period that we are looking at, let's use as an example a week, we are producing first product A, then we're producing product B, then C, then we have room for make to order items that are falling and can drop into the schedule. Then we're producing product D, maybe on Wednesday. Then we have another slot for make to order items, and Thursday afternoon and Friday we're producing the entire lot of E. So what you see, the white spots in between, is the setup time, and if you look at the spoke of each item, the wider it is, the longer it takes to produce it, or the bigger the lot size is for these items. Now, if I had some free availability on Friday afternoon, this concept would then suggest that you cut the lot sizes in half and therefore introduce more setup times in between the individual lot sizes, and therefore fill up Friday afternoon to its full capacity. That would mean that we are making some of A on Monday, some of A on Wednesday, some of B on Tuesday, some of B on Thursday, and so on and so forth. That would give us more flexibility, and it wouldn't cost us anything in overproduction because we are not making more product. We are only making what's demanded, but we have a lot more flexibility. So should it turn out that we're needing more of B rather than A, then we have the advantage that we didn't produce all of A on Monday, but we can actually cut the lot size of A that stands right now on Wednesday and produce more B instead. The way this kind of stuff is conducted again is by way of the strategy profile that you can maintain to your liking. So each one of these methods that I'm explaining here can be defined and identified through a various dispatching sequence inside of a various strategy profile. So there is a lot of customization available here that you can develop actually any production scheduling method you can imagine. And then there are the tools of repetitive manufacturing in SAP. When back in the days when you could buy R2 or the first versions of R3 software from SAP, everything actually was geared towards discrete manufacturing. And SAP noticed that there are some companies out there that are repeatedly producing product over and over, and that they actually would need some different functionality than a jumbled job flow shop would actually need. So they developed the tools of repetitive manufacturing, which gives you a lot of ease of use, makes things a lot less work intensive. You don't have to convert planned orders into production or process orders. Anything that's generated out of the MRP run is executable right away. They are called run schedule, and they can also automatically be put into slots in the production schedule by way of a strategy again. And this kind of thing is happening in MF50 in the planning table, or graphically out of MF50, or also you can call up transaction LAS2. I'm not quite sure why that is, but for some reason the repetitive manufacturing module doesn't enjoy wide use of it in the user community for SAP. It's, in my personal opinion, a fantastic tool to drive automation into your production scheduling process and also gain a lot of visibility, as we can see here. But I remember that in the early 90s when this module was developed, it didn't quite immediately work very well. There were a lot of bug fixes that needed to be applied, and maybe that ticked off a lot of people, and then they never looked at it again. But the way I have been using it lately with my clients, it's a wonderful tool that gives you a lot of automation, and it does take a lot less work. And another advantage of repetitive manufacturing is that the costing is actually material based and not order based. So you are actually comparing costs for materials on a period basis for the material and not for each individual order, which should be a big advantage, especially for repetitive manufacturers that make product over and over again. As per my experience, it's mostly the accounting people that are actually against the use of repetitive manufacturing, and I really do not quite understand that, because I think there's where one big advantage actually lies. But in any way, in repetitive manufacturing, if we are putting together a schedule like the one that we're seeing here, you get a number of great visuals here. What you're seeing here is a timeline for a production schedule for March 19, 2012. What you're seeing here is on the workstation that we're looking at is available from 7 o'clock until 4 p.m. in the afternoon. You're seeing 2 maroon orders being scheduled, from the first one from 7 o'clock to 7:30. The second one starts at 7:32 and runs to about 8:05. And then there's another 2 pink orders coming in. What you're also seeing on there is that we can identify a color code for each material so that we can see when we're switching from, on the mixed model line, when we're switching from one material to the next. We can also color code the material availability check that can be performed collectively on a repetitive line for all the orders that are running on it for any given week. We can say if we have a green diamond on any order, on any bar, the availability check was successful and all materials are available. If the diamond is red, we know we have missing parts for that order and need to expedite something. And then the third thing that can be visualized is for make-to-order items where a customer order was dropping into the line into free available capacity that we can leave open. We can see that there is inside the yellow bar, there is inside of it is a red bar. And if that bar is red, it means we're falling behind on the delivery date of that customer order. If the bar would be green, we would be operating ahead of the requested delivery date. And if it's yellow or brown in this case, it would mean that we're right on time. So this is what a finalized schedule would look like. What we're seeing here is Thursday and Friday to the left, and then there's Saturday and Sunday non-working times. It's grayed out, and we're starting again Monday, Tuesday, and Wednesday, and the orders were sequenced according to the strategy. They have their availability checks done, at least on Monday. There is one make-to-order customer order in the mix. And what's to be noted here is that we're scheduling the line only up to 80% capacity. So we're leaving, what you can see there is that there's some white spots, some white area for every day. That's free available capacity for any make-to-orders to drop in. This is something that you should consider on a line, because if you schedule a line to 100% and you have any variability coming in, the line goes down sometime, you have missing parts or a demand falls off. In that case, you would have no wiggle room of any kind to adjust or expedite to it. But if you leave about 20% open, you can deal with that variability. Moving on to the next method, Heijunka load leveling. Heijunka load leveling comes from the Toyota production system, and it is meant to level your production, to cut your lot sizes into the smallest possible lot size, and to produce every item or every part, every interval. That's what EPEI stands for, every part, every interval. The idea behind this is if your intervals are day, you're making every product, at least a little bit of it, from each material every day. That gives you utmost flexibility, keeps your lot sizes down, ensures utmost flexibility in expediting and rescheduling, but it does require a lot of setup time. So you have to find a balance between that and your setup time. Heijunka leveling can be done in repetitive manufacturing, but it can also be done in discrete. You see on the left, you see the Heijunka planning profile being used in repetitive manufacturing in the scheduling of the LAS2 transaction, whereas on the right you see the strategy profile that we discussed before in CM20. Let's look at the Heijunka board in CM25. You see a primary and an alternate line, a secondary line up on top that we can schedule to. You see the pool of orders on the bottom, and then you can see how the strategy profile is sequencing the orders according to a Heijunka strategy and distributes it on the line up on top. First it distributes or sequences the materials orders, and then it dispatches it out on the primary production line where these operations are meant to be executed. In repetitive manufacturing, however, in LAS2, this looks a little bit more streamlined and is a lot more automated because the MRP run generates all the orders that are required to be produced in a given period. And if you call up LAS2 with a certain profile, in this example the Hechunka profile, it simply takes all those orders from that period and sequences and levels them out across the production line. You can have alternates here, of course, too, and schedules every day up to 80%. Whatever is left over from any given period will be displayed in the section down below that says orders not yet dispatched, and you can take some manual action and put them actually into the remaining 20% and schedule manually that way. But as a first run, everything is done automatically right out of MRP and LAS2. And here is something that I consider very interesting. It's the TAKT-based scheduling of a repetitive line. If you're looking at an example of Lego parrots being manufactured on 6 different stations, where the last one is the packaging, but each station performs a certain task. So I was at a customer where I received a plant tour last year, and the plant manager was showing me around and showed me one of their repetitive lines, one of their assembly lines actually. And as we walked up to the line, he showed me that there were 2 stations. On the first station there was no worker, and in front of the second station there was a lot of inventory build up. And the plant manager got a little bit upset because he explained to me that he told the worker not ever to do more than one piece and not to work to inventory and then disappear. But the worker was obviously intimidated because he didn't want to stand idle and just process one part when there was like a large break in between. The problem was not the worker and what he was being told. The problem was that the cycle time on station 1 was a lot shorter than the cycle time on station 2. That means the worker on station 1 was able to produce a lot more parts that were piling up in front of station 2, where the worker was taking twice as long and had twice as many things to do than the worker on station 1. That inventory buildup disrupts the flow of material, and the way you counter this kind of thing happening is by way of balancing the line. And you can balance the line with the tools of repetitive manufacturing and a TAKT-based schedule. And that's what we're going to talk about now. In repetitive manufacturing, you don't have to, but you can use a so-called rate routing. I find this the name a little unfortunate. The German term for this kind of object is Linienplan, which, when you directly translate it, means production line route, which I deem a much better term. In any case, it allows you to build a graphical display of all the feeder lines and the main production line and all the operations that are required therein. And in that line route or rate routing, you can then indicate which ones are non-value added tasks and which ones are value added tasks. That means you can adhere to lean principles here and do some evaluations and where you can shorten the cycle times. Of course, you can also detail the machine time, setup time, and move times and things like that, much in the same ways in the regular routing. And then as a basis for your line balancing, you can identify the rates you can run on the line. This is being built in the line hierarchy. You create the line balance, and in this case we have a planned run of 150. We have 600 minutes available, and therefore the TAKT is 4 minutes, and that TAKT is important so that you can balance the line, because if you have a TAKT of 4 minutes and line 1 is done, station 1 is done in 2 minutes, and station 2 needs 6 minutes, That's where this pileup of WIP happens in front of line 2 of station 2. So here is exactly what I was just talking about. We have on that operation line A30, we have a violation of the TAKT time. Instead of 4 minutes, we're using 4.1 minutes, and this can be graphically represented in this screen. And you see the red part there is the violation of the TAKT time of 0.1 minutes. So what you can do now there is you can drag that operation and move it into another area so that the TAKT is not being violated, or you can break down the operations into smaller pieces, or you can increase the TAKT time, whatever you need to do in order to balance the line. Meaning, and that's what balancing the line essentially means, is that every TAKT is take about approximately the same time, and that every station is actually having a cycle time of approximately the same, so that we achieve utmost flow and minimize the WIP piling up between stations. Another huge advantage of repetitive manufacturing, the tools for repetitive manufacturing, is the fact that you can perform a collective availability check for all the orders that are running on any given production line in any given period. For example, for next week, you can run a collective availability check for line 100, and it will give you a status for every order on whether there is missing parts or whether the availability check was actually coming back with a good result. Out of that, you can print a list of missing parts and hand this over to your purchasing department, and they can then expedite what needs to be expedited, and the production scheduler can manually maybe move some orders and just make sure that no order is being released that has missing parts, because that order would have a very increased cycle time because it's staying open from the time it was released until the time it can actually be started. Last but not least, the production list for repetitive manufacturing. This is transaction MF51. Once you created your schedule, once you adjusted and expedited orders and put your manual schedule or automated schedule together, you can simply print the list with the sequence of all the orders that are to be executed in that sequence, and you can hand it down to the floor, and then you can either tell them that they should strictly work according to that sequence, or you give them a list and let them work a little bit more autonomous and tell them, look, these are the orders that need to be finished before Friday. Find the best sequence yourself, and but make sure that on Friday we have each one of these parts available. TAKT-based scheduling with Kanban withdrawals. Again, you can balance a line, create a schedule based on rates, where you take the demand and split and capacity level your line based on the available rates you have, on the planned rate or the actual rate. The only difference is that in this case, all you do with that schedule is you reserve capacities. But the actual execution does not happen according to the schedule. The workers are instructed to not execute according to the schedule, but to strictly execute according to the Kanban board. Now, in that Kanban board, the worker can see on the demand side of the Kanban board, can see when a container becomes empty and therefore needs to be filled up again. That means when a demand was occurring for a certain product, in this case a Lego parrot. In that case, the worker is strictly executing according to the demand that shows up in Kanban. So every time a customer orders one Lego parrot, then the worker executes one and releases it into the line. There should be free available capacity for that parrot, for that specific order, for that variation of the parrot, because we have a schedule that was based on planned demand, and that schedule is reserving capacity for the individual variations of the parrot. So whenever a Kanban order comes in, it replaces the scheduled bar for that very specific material with the blue bar. The blue bars, and you can color code this in any way you want to, the blue bars are those that are coming from Kanban. So a Kanban real demand, actual demand, would replace a scheduled bar in the schedule for that material that the real demand was coming in. You can also display a list up on top, and you see within the red frame, you see those two orders that were coming in through Kanban. They replaced two orders that were scheduled for that specific material that was actually demanded. So this is a real pull system where we actually put a schedule out for capacity reservations, but we're actually executing strictly to real demand. That requires that at the line are all the materials available that we need for the final assembly, of course. That's that inventory order interface that we talked about before. And then a quick word to make-to-order production that can be executed with a forecasted production schedule on the line as well. As mentioned before, we are not scheduling the line based on a forecast to 100%. We leave some room in there. And when you use strategy 81, 82, in your make-to-order items, when an actual customer order comes in, that customer order creates right out of the customer order a production or runs production order, process order, or run schedule right out of the sales order and places it right into the production program wherever there is free available capacity to the requested delivery date. So that assemble to order strategy, that is strategy 81 or 82, does really do some wonders, and you can see the order. If you double click on the bar, you can see the customer related order, the sales order right there in the picture, and there is a run schedule or a planned order directly connected to the sales order, which means that if the bar becomes red inside, which means we're too late, the delivery date in the sales order can, if we choose though, be adjusted at the same time and automatically. And now we're getting to the last production scheduling method that I want to discuss here as part of a standard SAP ERP setup, and that is drum buffer rope. I actually had a lot of people talking about it and asking questions about it. I have been blogging about it as well. Drum buffer rope comes from the book The Goal by Eli Goldratt. He is credited as being the inventor of the theory of constraints, and his method of scheduling is according to drum buffer rope, where he claims that one should identify the bottleneck work center, and from the bottleneck work center should give the TAKT to which everything else should fall in place. So that's the drum, and in front of the drum to the upstream side of the value stream, there should be a buffer of inventory so that to that TAKT we can always fill that work center. And to the downstream side of things should be the rope that is pulling from the bottleneck to actual demand. That's the concept behind the theory of constraints or drum buffer rope. And of course we can fix this in SAP ERP as well, standard tools. If we are looking at our Lego model again for that particular production line, we have actually implemented and used quite a mix of production scheduling method, but they're all standard SAP methods. What we decided to do is we wanted to make sure that we're pulling through the bottleneck, those blue Legos there, that we're pulling through only what is actually needed, because we got to be very careful, because it's our bottleneck, and we shouldn't pull anything through or make any product that we don't necessarily need, because we have limitations there. So the way we've done this is we put some inventory in front of the packaging line that we can pull from the packaging line, and that through a convip process, when a Kanban container becomes empty, we use collective orders and connect actually the production of 3 different items and pull exactly those through the bottleneck. To the upstream side, which in this case unfortunately is a little bit upside down, but it's to the right in this case. To the upstream side, we are pushing material into inventory using a component forecast VSFB, and there we're time phasing the planned orders that are coming out of the MRP run so that we can schedule them with CM25. And for the raw materials, we have used optimized measures to bring in the stuff from the vendors according to a mix of consumption-based planning methods and deterministic planning. So you see almost everything we talked about in this session is being used on this line. And if you connect the dots, you can see that this actually corresponds to a drum buffer rope scheduling method if you put the pieces all together. Now there's only one more thing that I want to mention before we conclude the session, and that is how you track exceptions and actually safety stocks or inventory on these items that you're production scheduling with these methods in a somewhat automated way. I recommend that you're actually driving how the supply is being generated to create and maintain a safety stock on any one of those materials that you're manufacturing by way of a coverage profile, in which you can say, I want to have something like 15 days of supply or coverage in my safety. And if you set the lights accordingly, then you would say anything that has less than 15 days in safety is becoming a red line. Everything between 15 and 20 days is okay and gets a yellow light, and everything that's above 20 days of coverage has too much inventory and therefore gets a green light and is a prime candidate for some inventory reduction purposes. So you can gain in the stock requirements list in MD07, you can gain a quick overview where your production is meeting the demand correctly with leaving some safety stock and where it is not. This concludes our session on effective production scheduling methods in standard SAP ERP. If you have any questions, please don't hesitate to contact me. This was the session that was conducted at the 2013 Sapphire ASUG conference. Thank you very much.